You are welcome to our last video on the series of naming of alkanes or alkane nomenclature, but more specifically for this one, I'll be looking at haloalkanes. So if you've watched with us from straight chain alkanes, and then we move on to branch alkanes, while taking a detour a little to look at alkyl groups, and then finally on our haloalkanes, and I think you've done marvelously well. But if you haven't watched how to name straight chain alkanes, how to name branch alkanes, and how to identify alkyl groups, then to be ideal to also watch those ones before watching this, or after watching this you watch those ones so that I have a complete understanding of alkane nomenclature. So that being said, if you haven't subscribed to our channel yet, quickly do that so you already miss future interesting videos. So let's get started. What exactly are haloalkanes? What are they? You see, haloalkanes are also known as halogen alkanes. What are they? They are organic compounds derived from alkanes. So first of all, they are derived from alkanes in which one or more hydrogen of the alkane has been replaced by a halogen atom. And when we are talking about halogen atoms, we are referring to group 17 elements like fluorine, chlorine, bromine, iodine. That's what we are referring to as halogen atoms. So let's look at this. This is a straight chain alkane. But imagine this straight chain alkane in this straight chain alkane, before even we move on to the explanation, take note of this. This straight chain alkane can also be written this way: CH3, CH2, 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 CH3. The one at the top is known as the displayed formula. We've already discussed that earlier. And then the one at the down is known as the structural formula. The one at the down tells us how or which atom is bonded to a particular atom. Basically, that's the difference. If you want to understand that more, you can look at an entire playlist for module 1 and understand what we're talking about. So let's continue. For this is an alkane, a simple alkane. More specifically, 5-carbon alkene is a pentane. So assuming or imagine these two hydrogens have been removed and replaced with a halogen, then we have a haloalkane. Is that not simple? Yeah, I think that is simple. As simple as it can get. So this is an alkane. The circled hydrogens can be any of the hydrogens. If you replace even 1, 2, or 3 or more hydrogens with a halogen, they have a haloalkane. So for example, imagine we replace this hydrogen here with iodine and bromine. So the first hydrogen has been replaced with iodine, indicated with I, that is I for iodine, and Br for bromine. Then you have a haloalkane. This haloalkane, this is the displayed formula. For the structural formula, it can be written this way: the first carbon is bonded to 3 hydrogens, the second carbon is bonded to 2 hydrogens, then the third carbon out there is bonded to a hydrogen and an iodine. That's why I have CH into brackets I. Then the fourth carbon is bonded to a hydrogen and a bromine. That's why I have CH and Br. Then the last carbon is bonded to 3 hydrogens. I think that is clear. Good. So that is how haloalkanes are formed. But how do we name haloalkanes? Because that's our focus. Nomenclature of haloalkanes. So rules for naming haloalkanes is the same as naming the other alkanes, especially the branch alkanes. But this time around, the methyl groups or the alkyl groups have been replaced by a halogen. So step number 1, identify the longest continuous carbon chain, and this becomes the parent chain. The longest continuous carbon chain, we are referring to series of carbon atoms linked without interruption. That is the longest continuous carbon chain. That becomes the parent alkane. And for this is the longest continuous carbon chain. Longest continuous carbon chain. anything attached to the longest continuous carbon chain or any halogen attached to the longest continuous carbon chain becomes a substituent. So this longest continuous carbon chain is known as pentane. Why is it called pentane? Because it has 5 carbons out there. We have 1, 2, 3, 4, 5 carbons. If you are not too sure how we came up with pentane, then there is a link to the video of how to name straight chain alkanes. I think that will clear all your doubts. They can come back and continue with this. And if you already know, then that's fine. Thumbs up to you. So step number 1 again, identify the longest continuous chain, and we've just done that. It contains 5 carbons, so the parent chain is pentane. Now, the I and the Br are known as halogens. I and Br are known as halogens. They are attached to the parent alkane, right? Now, step number 2 is to do what? Is to number the carbon atoms in the main chain from the end closest to the halogen. The end closest to the halogen, right? So let's number the carbon in the parent chain. Let's number the carbon. So we have possibilities. We can number from left to right or right to left. So for the left to right numbering, that is indicated by the red ink or red numbers. So we have 1 all the way to 5 at the top. Now let's number from right to left. For this we are using blue, so you have 1, 2 all the way to 5. Now take a very close look at the positions of the halogens. Where are they located? Have you seen that? For the red numbering, the iodine and the bromine, or the I and the Br, are found on carbon number 3 and carbon number 4. 3 and 4. What about the lower numbering from right to left, the blue? They are found on carbon number 2 and 3. 2 and 3 are low. So we see number the carbon atoms in the main chain from the end closest to the halogen. So that means we disregard the red numbering and focus on the blue, because the blue gives us the lowest possible location for the halogens, I and Br, iodine and bromine. Now that has been sorted out for us, right? Now we have to name the halogens as substituents. Are you ready? We have to name the halogens. Now for naming halogens, bromine, which is Br, is named bromo, and iodine, which is I, is named iodo. So let's see. So you have iodo for I and bromo for bromine. And this has also been stated for us already by IUPAC, how to identify and name these halogens. Now the next step is to assign a number to indicate where the halogen or the substituent is attached to the parent alkane. So you see the iodine or iodo is located on carbon number 3, and then the bromine or bromo is located on carbon number 2. So you have 3 iodo, 2 bromo. And now what we have to do is to combine the substituent name plus the parent name. For this, are we going to write 3 iodo, 2 bromo? Or we are going to write 2 bromo, 3 iodo? Of course, we are going to arrange them alphabetically. So what do we have? We have A, B. So B comes before I. So the name will combine this substituent to the parent alkane. So what do we have? We have 2 bromo, 3 iodo pentane. Let me explain the name. 2 bromo, 3 iodo pentane. The first part of the name, that is 2 bromo, tells us that there is a substituent called bromo, or which is a bromine attached to carbon number 2 on the parent alkane. And then there is another substituent, which is iodine or iodo, attached to carbon number 3 on the parent chain. And pentane tells us that the parent alkane has 5 carbons. So 2 bromo, 3 iodo pentane. And take note of this. After the 2, we have a hyphen before bromo. So hyphens are used to separate numbers from words. So 2 hyphen bromo hyphen 3 hyphen iodopentane. So we have to master how to use the hyphens and the commas, and that will be made clear on the next slide. There is another issue has to be tackled on the next slide. That is the presence of multiple halogens. What do you mean by multiple halogens? That means more than one halogens, right? Yes. So in this compound, you can see that we have Br somewhere, we have I, we have Cl, we have another Cl, we have another I. 5 halogens present on a single organic compound. So how do we name them? For that, the rule is this: you should always arrange them in alphabetical order. Alphabetical. Then if a halogen repeats, you can see that iodine appears twice. So you are going to use prefix like di or tri if they appear how many times? 3 times. And then the next rule is to use the lowest possible locant. So let's get started with this. Now let's go through the steps again. We have to identify the longest continuous chain. And for this, the longest continuous chain is obviously from end to end. And when we say longest continuous chain, we are referring to uninterrupted link of carbon atoms. So we need the carbon atoms to be linked to each other and it shouldn't be interrupted. So for this, we have it as from end to end. So that will be identified for us. Now, any halogen attached to the main chain becomes a substituent. And what are the halogens we have? We have Br, I, Cl, I, and another Cl. All of these are halogens. And we have more than one halogen, so we have multiple halogens. Then the next thing we get to do is to number the parent chain, the longest continuous chain. We have possible ways of numbering. We can number from left to right or right to left. So from left to right numbering, which is indicated in red, we have 1 to 8. Now we have another numbering from right to left, done in black. So from right to left, we still have 1 to 8. Good. That's been done for us. So let's look for the location or the positions of the substituent or the halogens. What are the locations? For the red, if you focus on the red, the numbering at the top, that's from left to right, you can see that the bromine and the iodine, the bromine at the top and the iodine at the down, are located on carbon number 2. Then beside the bromine, we have another iodine, which is located on carbon number 3. Then we have chlorine and another chlorine, all located on carbon number 4. So here are the positions of the halogens. We have 2, 3, and 4. Now, what about the lower numbering from right to left? For that, if we start from the right side, you can see that the 2 chlorines are located on carbon number 4. And the iodine is located on carbon number 6. And then we have bromine and iodine located on carbon number 7. So their position will be 5, 6, 7. That is huge. Because if you look at the sum total of the location for the red numbering, that is 2 plus 3, that gives us 5. 5 plus 4 gives us what? That gives us 9. But look at the black numbering. 5 plus 6, 11. 11 plus 7, that gives us what? 18. So 18 is way, way bigger than 9. So we would disregard the black numbering. That is the numbering from right to left and focus on left to right numbering indicated in red. Why? Because that gives us the lowest possible locant positioning. So I think we've sorted out those ones. The next step is to name the longest continuous chain. The longest continuous chain, how many carbons do we have there? We have 8 carbons. Guess you see it right? So since there are 8 carbons out there, the name of the longest continuous chain is going to be what? Octane. Remember octagon? Yes, octagon. So octane. So octane. Now if you don't know how we came up with the octane, then I'll urge you, advise that you go watch the lesson on how to name straight chain alkenes, and that should clear all your doubts. Now we are done naming the parent alkene as octane. What do? We have to name all the halogens present that are serving as substituents. And for the first one, we have bromo. For the I, we have iodo, chloro. So we have bromo, iodo, chloro, and then at the down we have iodo and chloro. We are done naming the halogens. So does that mean we are done with the name of the compound? No way. The next step is to attach the location of the substituents. So for the first bromo at the top is found on carbon number 2. So we have 2 bromo cleared. What about the iodo? It's found on carbon number 3. The iodo at the top, carbon number 3. The chloro is found on carbon number 4. And then the chloro at the down is also found on carbon number 4. And the iodo, final iodo, is found on carbon number 2. So we have 2 bromo, and then the remaining ones following the order. Now what do? We have to combine all these names with the parent name as octane. But what are the rules? We have to arrange them alphabetically. So to arrange alphabetically, what do we have? B will come before C and then I. So bromo will appear first, then chloro, then iodo. So alphabetical arrangement has been sorted. Now with the prefix, we have to use di if there are 2 of the same halogen. And we have to use tri if there are 3 of the same halogen. But for this one, I don't have any halogen repeating 3 times. We only have them repeating 2. So for the bromo, we have only 1 bromo out there. What about the chloro? We have 2. So we have dichloro. And for the iodo, we also have 2. So we have diiodo. So let's combine all of these to a single name. After that, we'll explain. So for this, we have 2 bromo, 4,4 dichloro, 2,3 diiodo octane. Whoa, holy moly. 2 bromo, 4,4 dichloro, 2,3 diiodo octane. This name is long, but it's simple to understand. Let's explain. The 2 bromo means that there is a bromine found on carbon number 2. Then the 4,4 dichloro, the dichloro, tells us we have 2 chlorine atoms present. That's why I have dichloro. And then the 4,4 tells us the position of these chlorine atoms on the longest continuous chain. And they are all found on carbon number 4. That's why I have 4,4 dichloro. Then we have 2,3 diiodo. Iodo means there's an iodine atom present, but di means there are 2 of them. And the 2,3 tells us that the first one is located on carbon number 2 and the second on carbon number 3. And octane tells us that the longest continuous chain of the parent alkene has 8 carbons. Good. Now what about the hyphens and the commas? Look at the 2 bromo. Right after the 2, we have bromo, and the 2 is separated from the bromo by a hyphen. Why? Because the bromo is a word and the 2 is a number. So separate numbers from words with hyphen. Now, right after the bromo, we have another hyphen and then a 4. The 4 is a number, the bromo is a word, so we use hyphen to separate words from numbers. But look at the 4 and then the 4. Since we have 4 and 4 side by side, we separate them with a comma. So 4, 4. I think you get the rest, right? Look at the 2, 3 diiodo. The 2 and the 3 side by side, we separate them with commas. So take note. Separate words from numbers with hyphen and separate numbers from numbers with commas. So this is how interesting it can get. And I think you've mastered it now and you are good to go, right? But before we proceed, let's look at some common halogen substituents. We have fluorine And if it is a substituent, it's written as fluoro. If it's chlorine is a substituent, it's written as chloro, bromine as bromo, iodine as what? Iodo. So take note, some alkanes or some organic compounds or alkanes have both halogens and alkyl groups as substituent. So that if that becomes the case, you need to apply the knowledge from how to name branching alkanes that have alkyl groups as substituents, and then how to name haloalkanes. Good. Now we have some quiz question here for us. Quiz question. Okay. So name the following compounds. CH3. All these compounds have been written in their structural formulas. So if you are comfortable with how to name it directly with the structural formulas, good for you, you can proceed. But if you're not comfortable with the structural formulas in this way, you can expand the structural formulas into displayed formulas and then name it. But for the purpose of teaching, I'll do it side by side. The structural formula at the top, then I'll write the displayed formula at the down. So for the first one, number 1, this is the structural formula: CH3, CH2, CHCl, CH3. So this is its displayed formula. What you see at the top is the same as what is at the down. The first carbon is bonded to 3 hydrogens. You see that, right? The second carbon is bonded to 2 hydrogens. The third carbon is bonded to a chlorine and a hydrogen. So the third carbon has a hydrogen and a chlorine. That is written as CHCl. Then the last carbon is bonded to 3 hydrogens. So how do we name this compound? Step number 1, identify the longest continuous chain. It's obvious for us. So we have to number these carbons. So for the structural formula, this is how to number the carbons: 1, 2, 3, 4. And for the displayed formula, is the same way of numbering. So you can number from left to right or right to left. So from right to left, you have 1, 2, 3, 4 in red. Displayed formula. And take note, what I'm doing at the top is the same as what is happening at the down, so there's no difference. I'm just adding the displayed formula for those of us that have actually not gotten a strong hold on the structural formula yet. So now the position of the halogen for the number at the top, that is left to right, the black numbering is 3. But if you focus on the red number from right to left, it's found on carbon number 2, which means we are supposed to pick the one that the chlorine is found on carbon number 2. So we disregard the black numbering. So what will be the name of this compound? That will be 2-chlorobutane. Straightforward, easy peasy. 2-chloro tells us that the chlorine is found on carbon number 2, and butane tells us that the alkane has 4 carbons in the longest continuous chain. That clear for us? Question number 2. Good. So CH3C, bracket opens CH3, another bracket opens Br, then CH2, CH3. This is a structural formula. How would we draw the displayed formula? That's what you have on the screen. This is the displayed formula of the structural formula I have on the screen. Let me explain. You see, if you look at the longest continuous chain, the uninterrupted carbon, the 4, 1, 2, 3, 4, counting from left to right, carbon number 2 has bromine at the down and CH3 at the top. So look at the structural formula. On the second carbon from your left, there is bracket open CH3 and another bracket opens Br. So what that means is that when you see a structural formula and a bracket has been created in front of a certain carbon, know that whatever is in the bracket is attached to the carbon outside the bracket. I hope that's clear. So now let's go through the steps. Step number 1, we have to number the carbons after we have identified the longest continuous chain. So we have 2 ways of numbering. You can number from left to right or right to left. And if that, now let's do that for the displayed formula. Already done. Now let's repeat from right to left for displayed right to left. But it's obvious that the numbering from left to right, that is the number at the top indicated in black, gives the methyl group, the substituents, a number of 2, and the bromine also a number of 2. But if we focus on the red numbering, it gives numbering of or position of 3, which is huge. So we disregard the lower numbering and focus on numbering from left to right. Now, what will be the name of this compound? That will be 2-bromo-2-methyl-butane. So that means halogens come first before alkyl groups. Good. So 2-bromo-2-methyl-butane. 2-bromo. So this is what I referred to on an earlier slide. There are some alkanes that have both an alkyl group and a halogen attached to the longest continuous chain. So 2-bromo tells us that there's a bromine attached to carbon number 2, and 2-methyl tells us that there is a methyl group attached to carbon number 2, and butane tells us there are how many carbons in the longest continuous chain? 4. Okay. What about the last example? With that, I'm not going to answer it for you. Write the name in the comment section, and I'll read through and give you thumbs up if you get it correct, and I'll still give you a thumbs up if you get it wrong for trying. So this brings us to the end of naming of what? Alkanes. We started off with straight chains, branch chains, and then we've ended with haloalkanes. Now our next lesson is isomerism. Isomerism. It reminds me of isosceles triangles. Isomerism, does it have anything in common with? Can understand isosceles triangles help us understand isomerism? What is the meaning of isomerism? That will be the topic we'll be discussing in our next lesson. So now we know how to name alkanes. Is it possible the same molecular formula can give you different structural formula? That will be the focus of our next lesson. See you